So once you have recorded some data, you'll get something like this. And at the bottom here, I have uh, two sets of data. One for just the box on the spring. Well, um, well, it was held close to stationary, and one for while it's oscillating. So you can see that these don't vary a whole lot, but they go from 0.44 something or 44 centimeters something to 0.46 or 46 centimeters something. So to use this as just a position, I would just average and then just select all of it. And oh, that's not what I wanted. Well, it doesn't really matter, but and I would use that value as my position. So I would say that for and you probably want to record, this was, the math was 0.0359. Actually, I put 0.7, but the box is actually 0.9. In my case, this will be different for you. But so this would be my position, and this would be my mass for this set of data. And then, I just do that for multiple different masses. And there is a table in the lab manual that you can fill out based on that. And I'll show you what we'll be doing with that later. For the case where it's oscillating, let me get rid of this. So here I have data, and you can see that it is varying more. And you may run into a problem. You'll have to mess with this a little bit. If you pull the spring too far, it's just going to go all over the place. You should only stretch it a little bit. And even if you only stretch it a little bit, it will, at first, it will oscillate up and down, but it may start swinging or something like that. That is actually a problem with using a string, like I showed you on my setup. That will cause it to swing more easily. If you can set it up in a way where you just have it hanging off of something, like if you have, I don't know, a pencil or pen won't really fit through the hole of the spring, but if you had a thumbtack or a nail or something that with a thumbtack, you don't want to drive that into your table or whatever. But if you can set it up in some way where the spring is hanging directly off of something, that may work a bit better. But you can see that what I've done here is I graphed this as a scatter plot. So I guess I'll just go over that quickly just in case. So, I just want to insert a chart, choose a scatter. For some reason, it has not chosen the data I want. But I can go here, select that. Go here, select this, and it will make a graph of position versus time for me. So now what we want to do is measure the period. And so the period is the time from a maximum to the next maximum or a minimum to the next minimum. You don't really want to use the middle because it will get kind of more difficult because you need to make sure it's moving in the same direction. And you can see here at the end, it started cutting out and measuring the distance to probably the table that I have the spring hanging from. And that's fine. I can just use the data from before that. And since I'm not exactly at a maximum, but I'm close to it when I start, what I'm going to do is I'm going to use the minimum, the first minimum, and then if I measured to where my mouse is now, that would be one period, but I want to measure as many periods as possible just to basically average them all at once. So this would be 1, that would be 2, that would be 3, that would be 4, 5, and 6. So what I'm going to do is I'm going to find the time difference between this point here, which is somewhere around 38.5, and this point at the beginning here, which is somewhere around, I don't know, 35.4 or something. And actually, I already have the times up here. But what you want to do is go through your data. And so, like I said, from the graph, I can see this is 35.4 or so. So I look here and I find the lowest point in that area, and the time of that was this here. So I can just copy and paste that over to my initial time. And then, like I said, the last point I'm using is a minimum around 38.5. So I can scroll down in my data to 38.5 and then find the lowest point, which is this one. And I already have it up here. But those are my, what I'm calling T2 and T1. T1 is the time of the first point I'm using, and T2 is the time of the last point that I'm using. Now, like I said, I'm starting at this minimum, so the next one would be 1 period, that would be 2, 3, 4, 5, 6. So what I want to do is take the time difference between these two and divide it by 6. And so that's what I've done here is I did E2, which is the end time, minus E1, which is the start time, divided by 6. And so that gives me the period. I've also recorded the mass here, which again is 35.9 grams or 0.0359 kilograms. You should probably, I was a little bit sloppy here, but it's probably best to make sure you write your units on everything. So you can do that. And obviously this is just kind of scratch work that I'm using to find these values. But so I have my mass and I have calculated omega, which is 2 pi over the period, and it's in radians per second. And so you're going to do that for several different masses as well. So you're going to measure the stationary position or the equilibrium position, and you're going to measure the period and angular frequency of the oscillations. All right, so I wanted to quickly show you just kind of my process here for, taking the data and stuff. So what I have is I have a sheet like what I showed you before. I have the y position, which is the average of these values in the B column, which are the positions from the center. And I have the mass on one sheet, which I've got as the stationary sheets. And then I've got the oscillating sheets where I have a graph. And then I pick the times that I'm measuring the period between the number of full periods that those times represent. And then the period here, the mass and the angular frequency. And so, this time corresponds to this minimum, this time corresponds to that minimum, and there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 periods between them, which is the n that I have here, which then I just take the difference of those times and divide it by the number, and that gives me the period. It is very important to remember that you start counting basically at 0 with the first minimum or maximum. So I count that as 0, and then that's 1 full period. It will significantly affect your data if you, just count the number of peaks or whatever, because then the number of periods is the number of peaks or troughs minus 1. So you start at 0, that's 1 period, 2 periods, 3 periods, etc. If I want to do a new mass, what I would do is, if this bar will go away, I'm going to duplicate my most recent sheet, both of them. And I'm just going to add 10 grams, so I'll call this 75 grams stationary and 75 grams oscillating. Now I want to change the mass. That to 75. I can click and then control click and just delete all of that. It's not on, or you're not going to be able to see, but I will add my coins to the box. I will let it sit basically stationary. I'll go over to my Arduino, clear the output, type start, hit enter, record for a bit. Hit enter again to stop. Hit Control A, Control C to copy all of that. Come over here, paste it, split it into columns, and I have this set up so that it's averaging all of the B column. So that just automatically gives me the average, and I'm done there. Now for the oscillating, again, I can click on this and then hit on Windows it would be Control. I'm on Mac, so it's actually Command to select both of those, delete them. Go back over here, clear my output, type start, so that I'm ready. Let my masses oscillate some, start recording. Record for a while. When I think I have enough data, just hit enter to stop. Again, Command on Mac, A and C. It would be Control A and then Control C. On Windows, Control V to copy it, split it, and I have this nice graph. So now I would choose 2 points. So I'm going to choose this point, which is at about 1362. So I want to find the lowest data point that's near 1362. That would be this time here. Copy and paste that there. Now I'm going to do 1 period, 2 periods, 3, 4, 5, 6, 7, 8, 9. And that's going to be 1369-ish, probably 1368.7 or something, I don't know. But I'm just going to scroll down to around that time and find the minimum, which would be this value here. I may have already counted that this is 1 period, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 is the number. And again, this is for 75 grams, so I want to change that mass. And so now I have all of the information that I need for that mass. So you're just going to have to do that for, I would do 5 different masses. The tables, I think, have 5 and 6 different slots on, or different rows, I should say, on them in the manual. But I would just do 5 for both of them. And so you're just going to do that 5 different times.